Today we're going to start the unit on cell communication. And when we're talking about cell communication, first thing we need to know is, do y'all remember what a cell is? Like, so what is a cell?
Basic something that's made of
unit of a living organism.
The basic unit of a living organism. That's what we're made of, right? So my question to you is, are bigger organisms made of bigger cells or more cells?
More cells.
More cells, right. Because there has to be that correct, remember that surface area to volume ratio is how a cell remains efficient. So how is it that cells are able to communicate with each other? So that's the question we're going to answer today. And how many people have played the game? It's called, I think it's like telephone or something like that. Okay, so we're going to do that real quick, okay? So I'm going to whisper something to Shelby, and make sure you whisper. Nobody else needs to hear what you're saying. And Cammie is going to be my in person, and Cammie, whatever you hear is what you do, okay? When we talk about cell communication, there's 3 stages of cell communication. The first stage is reception, where a signal comes in contact with a receptor. That's the first stage, that's reception. The second stage of cell communication, you should be taking notes. The second stage of cell communication is transduction. So telephone is kind of like how we're going to do the transduction. I'm going to be the signal. Shelby's going to serve as the receptor. And once I give the signal to Shelby, she's going to start the transduction pathway that is going to go all the way until we get a cellular response, okay? The response is going to be the protein, the enzyme, or whatever it is inside of that cell that is going to do the thing that I want it to do. Y'all with me? Yeah. All right, so there's 3 stages of cell communication. What's the first one?
Reception.
Reception. What follows reception?
Transduction.
And what follows transduction?
Response.
The response. All right, so Awesome. Okay, so I was the what? You were the reception. I wasn't the reception. I was the signal. I was the signal. Who was the receptor? Who received the signal first?
Shelby.
So she was a receptor, and then what happened?
Transduction.
And what happened next?
Cellular response.
It didn't do it right. Hold on. All right. It scared you at first, right? What happened when you got scared?
She jumped.
You jumped. Okay, you jumped. But let's talk about more physiological. What happened?
She screamed.
She screamed. Okay. How did you feel?
Scared.
What else? Talk to me. What else?
I felt frightened.
You felt all right. You were startled. Okay. What about your heartbeat? What happened to it?
It sped
It sped up. Your heart rate sped up. Okay. What about your breathing?
up for a second.
Alright, so there is this thing called fight or flight. Have y'all ever heard of that?
Yes.
Alright, so today, while we're learning about cell communication, we're going to learn about what just happened to Terry when I dropped that book. So, cell communication, first things first, you must know the 3 stages. You must know how a receptor protein recognizes signal molecules, how a cell signal is amplified, an example of a second messenger, how a cell responds in the nucleus turns on and off genes, and also why apoptosis is important. So let's start with first how we even recognize that something's happening. What do we have up here on the board?
Cheetah and a
Cheetah and a gazelle. What do you think that gazelle is going through? The same thing that who was just going through? Terry, right. A fight or flight, right? So some of the things that we know, okay, so externally we know you scream, you jump, you get scared, your heart rate speeds up, your digestive system is actually going to slow down because your body is trying to get all of your blood where it needs to be. And it's trying to conserve ATP for your muscles, because if I get scared, what's the first thing I really want to do? Run, right? And so if I'm running, my muscles need more what?
blood.
Energy, right? It needs more energy, it needs more ATP, and it gets there. No, you're right. So the signal has to get to my cells, though, because this was an external stimuli that is going to trigger a cellular response. An external stimuli is going to trigger a cellular response. So I'm going from something outside, something big, that is going to trigger something so small in my body that I don't even realize it's happening, just so I can try to get away or fight. I'm a fighter, personally. What are y'all?
A fighter.
Fighter. Tasia, a fighter. Alright, so cell communication, we know about cell communication from several experiments that was done, but one of them that was done using the yeast Saccharomyces cerevisiae. There's two types of yeast, alpha and A. Okay, you have an alpha and you have an A. Now when you look at the diagram on the board, tell me what you see in the first model. What do you see here?
Two cells.
Two cells. What are they doing?
They're exchanging.
All right, so it looks like alpha is releasing something that looks pink, and A is releasing something that looks what? Blue. And what's happening to the pink thing?
It's
Going to the other one, right? And the blue thing is going to the what?
alpha.
To the alpha. They're communicating with each other. These yeast are getting ready to actually mate. An alpha can only mate with an A. And the way they identify each other is by releasing a ligand, L-I-G-A-N-D. A ligand is a chemical signal. They release a ligand, and that ligand is able to bind to the receptor on the cell. Kind of like enzymes. We say enzymes are like a what? Lock and what? Key. Lock and key, right? If the receptor doesn't fit, if the signal doesn't fit, will it have reception? No. So, the ligands that are released from alpha can bind to the receptors on A, and the ligands that are released from A can bind to the receptors on alpha. When they both receive the signal, they have a response, and the two cells mate to form a new cell. Okay? Y'all with me? Mm-hmm. This is a primitive example of cell signaling. This is a primitive example of a cell signaling pathway. You have a signal, reception, it recognizes that, so that's transduction, and then you're going to ultimately have a what? What's the last part of cell signaling?
Response.
A response. What are the three parts of a cell signaling pathway? What's first? Reception, followed by transduction, followed by response. Awesome sauce. All right. So let's talk about the different types of cell communication.
Yeah.
All right. I'm gonna come over here. Come close. We gonna talk to each other. Alright, so was I talking to her from a long distance or up close in person? So this is local. We're communicating locally, right? Mm-hmm. Hey, Tasia! Was I close?
No.
Alright, so that was what type of communication?
Long
Did she get the message though?
Yeah.
Alright, so we have local and long distance signaling when there's two types of cell signaling. Now, the two types of local are called paracrine and synaptic, okay? Paracrine is when a cell secretes a signal, something like maybe a growth hormone, and the neighboring cells that have the receptor, because only the cells that have the receptor for the signal can respond. Are y'all with me? Mm-hmm. Only the cells with the receptor for the signal can respond. So, in the paracrine signaling, a cell releases a signal, and all the cells that have that receptor receive the signal, and then they can respond to that signal, okay? In local type synaptic, what do you think that has to deal with? Synapses. When you hear synapse, what do you think of?
The space between the axon.
Yeah.
The space between the axon and the what?
And the neuron.
And the neuron. So what system is that? Nervous system. Awesome. So three of your main body systems that have to do with cell communication, cell signaling is your immune system, your nervous system, and your endocrine system. All three of those are rely on cell communication. Now, long distance signaling is endocrine signaling, also called hormonal signaling. Long distance is endocrine, also called hormonal signaling. So what do you think it's going to involve? If it's long distance, how does a signal get from somewhere in your body if it's traveling a long distance? How would it get to the cells? No, remember, nervous system is local, that's synaptic. Blood, exactly. It's going to travel through your blood. It's called hormonal because what do you think it deals with? Your what?
Blood.
Your what? Hormones, right? Your hormones. When you were a little girl before you hit puberty, things were different. Those little hormones started being released, and certain cells started responding differently, didn't they? But not all cells responded. Only certain cells and certain tissues responded to the hormonal signal. And it happened all over your body, not just in one location, because it was traveling through your what stream? Bloodstream. And every cell that had a receptor received the signal. Are you with me?
Yes.
All right. Now, when we think about cell communication, there are receptors in the cell. I keep saying that the cell received the signal. The signal was sent, the cell received the signal. Well, how do the cells actually get the signals? So there are three main transmembrane receptors. There's three main transmembrane receptors. We're going to talk about those three. Let me get to it. Here we are. This is the first one. The first one is called a G protein coupled receptor, or GPCR for short. It's a G protein coupled receptor, and this is the most common type of transmembrane receptor. The second one is called an RTK, or receptor tyrosine kinase. We're going to talk about each one of these in detail in a second. The second one is called an RTK, or receptor tyrosine kinase. The third one is the easiest one, so I'm going to talk about that one first, because it's simple. And the third one is called a gated ion channel. Ligand gated ion channel. What's a ligand?
A chemical signal.
A chemical signal. It's a thing that bonds to the receptor. What's a ligand?
A chemical signal that bonds to the receptor.
A chemical signal that bonds to the receptor. What's the first stage of cell communication?
Reception.
What's the second one? What's the third one?
Cellular response.
Cellular response. What's the thing called that brings the signal? What's the chemical signal?
A ligand.
A ligand, right. The chemical signal is a ligand. All right, so let's talk about the gated ion channel. These represent my ions. Okay, this is an ion. That never happened. All right, anyway, so this is the membrane, this is a receptor that's holding back the ions from coming out. What's going to bind to the receptor? What's going to bind to the receptor? We're not going to get you. What's going to bind to the receptor? A ligand. Ligand binds, gate opens, ions come out. Got it?
Yeah.
All right. Pick them up, throw them back. Come on. Hustle. Hustle. Let's get there. All right. We're in there. All right. So, ligand gated ion channel. Ions are held inside, they're on the other side of the membrane. We need to get to the other side. There's a difference in ion concentration, okay, across a membrane. But there is a protein channel that they can go through, but the protein channel is closed off. That's why it's called a gated, because it acts like a what?
Gate.
A gate. The gate can only open when a signal binds to the gate. When the ligand binds, the gate opens. What happens to the ions? They come out. When the ligand releases, what does the gate do? It closes. Can any more ions come out? No. Ligand gated ion channel, that's the easiest one. Y'all think it's all gonna be that easy? No. Of course not. This is me, right? Alright, let's go back to the one that you need to know the most about. Well, it's because it's the most common one. This is the GPCR, or a G protein coupled receptor. Now, a G protein coupled receptor has three main types of membrane, types of proteins embedded in the membrane. You have a G protein coupled receptor, a G protein, and an enzyme. The receptor is what we call a transmembrane receptor because it goes all the way through the cell membrane. Okay? Why is it called the transmembrane receptor?
Because it goes all the way through.
It goes all the way through. The G protein is a peripheral protein because it's on one side, and in this case, it's on the cytoplasmic side, so it's on the inside of the cell. All right, and the enzyme is an embedded protein that's embedded in the membrane. You have a little baggie at your table. Take it out, take it out. Oh, take it out. Okay. All right. What you said on my phone? You said about my mom. You like my son? Thank you. All right. I have extras in my bag. All right. Everybody should have. I want you to check and make sure you have a couple things. You should have a little blue guy that says he's a what? Ligand. This is your chemical signal. You should have something that says GPCR. You have that one? Everybody show me your GPCR. All right. You should have an enzyme, little purple guy. Enzyme. You should have a stop sign and a go sign. What does your stop sign say? GTP. And what does your go sign say? GTP. All right. You should have a G protein.
I'm missing them.
You missing a G protein? All right. Here you go, love. You missing the stop sign? You missing the what, baby?
Enzyme.
An enzyme. All right. That's why we check the bags before we get started. All right. Love. And you should have a relay protein. Everybody got a relay protein? Mm-hmm. And you should have a cellular response. That's love. All right. So you have a cellular response. So on your tables, I want you to do, right in front of you, I want you to take your GPCR, place it to the left, take your G protein, put it in the middle, and take your enzyme and put it to the right. That's what you should have in front of you. Got it? Put them in a straight line. See how they are right here? Put them in a straight line. Everybody good? Everybody good? Say good. Good. All right. Now, the G protein coupled receptor is called a G protein coupled receptor. Oh, do me a favor. Turn his mouth up on your G protein, like have it going up towards, like Pac-Man going up in the air. Like he should be like this right now. Okay. So your G protein coupled receptor is called a coupled receptor because it's going to couple with a ligand and a G protein. Okay? A G protein is called a G protein because it forms an association with an energy molecule called GTP and GDP, which is guanosine triphosphate and guanosine diphosphate, which is kind of like ATP and ADP, except the base is different, okay? Instead of using adenine, it uses what? Guanine. All right, so G proteins can be active or inactive. Right now, I want you to make your G protein active, so put the GDP on it at the bottom, and that's the stop sign. Stick that GDP at the bottom of your G protein, the stop sign. Just attach it to it somewhere on the bottom. We good? All right. What's the first step of cell response? Reception. How does reception happen? When what does what? The ligand binds to the receptor, okay? First step, say ligand binds to receptor. Whenever a ligand binds to the receptor, the first transduction will be a change in shape of the receptor. So take your ligand, and it should fit in your receptor. Receptor gets the signal. Everybody, let me see everybody. Ooh, say yeah. All right. I don't remember y'all say it. All right, so when you do that, I want you to turn your GPCR just slightly towards the G protein, okay? Now, you don't have to put it all the way because it makes a slight conformational change, and we know that structure dictates function. Structure dictates function. There you go. So when you change the structure, you change the function. Now, when that protein receptor changes its shape, the G protein knows it's time for it to go from inactive to active. So if the GDP is the stop sign, then what's the go sign? GTP. So it releases GDP and binds to what? GTP. Okay? Y'all ready?
Yes.
Y'all following along?
Yes.
Once it gets the go sign, it goes over to the G protein coupled receptor. Because I told you that is a what type of receptor? What's the C word? Couple. What does couple mean? Two. So it has to come in contact with how many things? Two things. The ligand and the G protein. That's why it's called a G protein coupled receptor. Y'all follow?
Yes.
Got it? Somebody's light bulb went off. All right, so once the G protein gets the signal, because we have reception and then what? What's the next step? Transduction. So it gets the signal and takes the signal to the enzyme. Take the signal to the enzyme. All right. What's it gonna do once it gets to the enzyme? Give it the what? The signal. Right, and we call that activation, okay? It's going to activate the enzyme. That's the G protein's job, to activate the enzyme. Once it does its job, it goes back into the stop mode. So it releases that phosphate from GTP to make it GDP all over again. Y'all with me?
Yeah.
The enzyme is now activated. The enzyme is going to catalyze a reaction by sending the signal to a relay protein. When you hear the word relay and you think of track, what does that mean? Running, but what happens? In a relay race, what happens? You pass the baton, you pass the baton, you pass the baton. So guess what the enzyme is doing with that signal in that relay protein? Passing the baton, it's passing it on. When the relay protein gets the signal, it passes it on to whatever enzyme or protein or whatever else is supposed to do the job. And then you end up with the last step of cell communication, which is the what? Cellular response. The cellular response. Y'all with me?
Yeah.
That's how a G protein coupled receptor pathway works. It's the most common. Okay? That's the most common pathway. It's also the pathway we're going to talk about with epinephrine. Now, mix it up on your table. Put it back together.
5.
Got 1 minute. When you think you're ready to explain it to me, hold up your signs. You got your I'm not sure, I got it, and I don't know it signs at the table. So when you think you're ready to talk to me, hold it up. And if you think you need some help, you got your other signs too. So you got it? You ready? Oh, okay. I thought you were ready. You ready? All right, let's go. GPCR.
Okay. It binds to it binds to this receptor, and then the GPCR gets the signal to go. So they connect, and then he passes out the message to the enzyme, and then that tells the enzyme, or that tells the G protein to stop, and then the enzyme goes to the relay protein to pass on the message to, and then you get the cellular response.
Awesome sauce. Woo, good job. Anybody else? Who ready? Come on. I mean, I can pick somebody random. I want at least 3 people to do it for me out loud. Okay, come on. Are you ready? Let's go.
So when this isn't, well, it is like this, but the ligand connects to this and it turns towards it, so that induces the stop is the go because now it's connected to each other.
But what are the molecules? What's the stop molecule and the go molecule?
The GDP and the GTP.
Okay.
And so then when this is activated, it moves towards this and it gets the signal, so then it takes the signal to the enzyme. And once it gives the enzyme the signal, it moves back to the middle and changes back to GDP. And then the enzyme gives the relay protein the signal, which makes the cellular response.
Awesome sauce. That's it. Good job. Who my other grade so? Come on. This table went. That table went. Come on. Cammy. Show me your confidence card first. What you think? You think you got it? You're not sure? Or you...
Yeah.
Yeah.
You got it. All right, come on. Talk to me.
So, the GPCR, right?
Mm-hmm.
Hooks up with the lignin, right?
Mm-hmm.
And then these two, yeah, they gonna come together, right? Because this is telling this to go, right?
Mm-hmm.
So when they hook up together, so this is gonna come over here to the enzyme, and that's called activation.
Mm-hmm.
So when this activates, this tells this right here to stop, right here.
Mm-hmm.
Yes,
Keep going. You good.
And then the enzyme, since it's activated, it's gonna take it to a relay protein, right?
Mm-hmm.
And then when it gets to the relay protein, it's
There you go, girl. Yeah. Your neck didn't even get hot this time. Did it? All right, y'all. So that's the GPCR. Now that's only one pathway, but remember I told you there's 3 pathways. We talked about how many so far? Two. We talked about the GPCR and the gated ion channel, right? Which one is the most common of those 2? GPCR. All right. So you can just leave them out for right now. All right. So now the third one is called the RTK. Okay. That's the receptor tyrosine kinase. It works kind of like a GPCR, except instead of having 1 receptor, it has 2. And there's 2 stages to activating this receptor. The first stage is the 2 receptors, they both have to be bound to a ligand. So a ligand has to come in contact with both receptors. Put your fingers on the thing. All right, so pretend like a ligand has come in contact with both of them, right? They're both receiving the signal. What's the first thing a receptor does when it gets the signal? It changes its what?
structure.
Right, change the structure somehow. So it makes what we call a conformational change. It's going to change somehow. So when both of these receive the signal, they come together and form what we call a dimer. Okay? So no signal, they're like this. They get the signal, they do what? And this is called a what? Dimer. All right, awesome. That's the first step of activation. Now, if you look up here, on the receptors, there are tyrosine molecules, right? Tyrosine is an amino acid, one of the 20 amino acids. Each one of these tyrosines has to be what we call phosphorylated by an enzyme called a kinase.